Imagine you are at an intersection with multiple roads. If we know the direction of each roads, then we can determine where they intersect. Systems of linear equations work in the same way, finding where lines, planes, or even higher dimensional objects intersect. Welcome to the first lesson of our Introduction to Linear Algebra series. Today we are diving into systems of linear equations, a fundamental concept that helps solve real-world problems in physics, engineering, and even economics. So what is a system of linear equation? So a linear equation is an equation where each term is either a constant or the product of a constant and a variable. No exponents, no square roots, just simple addition, subtraction, and multiplication. For example, we have 2x plus 3y equal to 6. This is a constant, so x and y are variables, and each term is either a constant or the multiplication of a constant and a variable. We cannot have any squares, any cubes, or any square roots like this. We cannot have those in a linear system, okay, in a linear equation. So a system, what is a system of linear equation? We know what is a linear equation. This is a linear equation. We can have another linear equation like this. So what is a system of linear equation? A system of linear equation is when we have minimum of two or more finite numbers of linear equations involving the same variables. The goal is to find the values of the variables that satisfy all the equations at the same time, right? X and y are the variables, and the goal is to find the values of x and y so that these values satisfy all the equations we have in the system. So a general linear system of m equations, a general linear system of m equations, in the n unknowns, like we have m number of equations, 1, 2, 3, 4, m, right? This 1, 2, 3, 4, 5, 6, and then the last one is m. And if we have n unknowns, like x1, x2, x3, x4, and so on, and the last will be xn, then this linear system, general linear system, can be written like this. So we will have m number of equations and n number of variables in the system, right? So this system is called the general linear system. Every system of linear equations falls into one of these three categories. We can have no solution of the system, and we can have only one solution. Also, we can also have infinitely many solutions of the linear system. So if we have only two, like the number of unknowns variables are two, like x and y, if we have, for example, this variable, this system is like this, x minus 1 equal 1. This is a linear system, okay? And this has only two variables and two equations. So in every equation with two variables represent a line, a straight line. So in this case, we can have like three possibilities of the solutions. So we can have one possibility, that is we will have one solution of the equation. In this case, so if we solve this system, then this line, both of these lines intersect in this value, right? So if we try to solve this system, we will find that x equals 3 minus y. If we replace the value of x here, this is y, by the way. So if we replace the value of x, then we will have 3 minus y, and then equal to 1. So that will be minus 2y equals 2y, and that will be, the y will be 1. The value of y will be 1. If we replace the value of y, we will get the value of x, and that will be 2. So we get the value of x and y, which are 2 and 1, right? So we can write the solution set. The solution set can be expressed by a ordered set, right? This is an ordered tuple. So this pair of number is the solution set. This is one solution set. So we can only have one solution in this system. Geometrically, we can define this theme that if two lines intersect in only one point, then we will have only one solution. Basically, the intersection point is the solution, is our solution set. So this point is basically 2, 1. Okay. Now, okay, right, let's write this clean. Okay. Now we can also have a possibility of infinitely many solutions. So if two lines, by the way, we have two lines here, right? Both of the line coincide. they are coincident lines, so coincide, they are like top of each other, right? So in that case, we will have infinitely many solutions because we have infinitely many points, many common points, that like many common intersection point, right? This line we have infinitely many point that is common between both of the line. Basically, that's the point, right? So this system is consistent and infinitely many. It has infinitely many solutions. So the equation, for example, if we remove this, if we have the equation like 2x, okay, if we have the equation like 2x plus 4y equal 8, and then x plus 2y equals 4, this equation, if we like monitor it very carefully, then you can see that this equation has infinitely many solutions. If we multiply this equation by 2, then we will actually get the other one, right? So in that case, if we see that the coefficients of the equation are like scalar multiplication, this is called scalar multiplication, scalar multiplication, we will know the term like in detail later. So if we find that one equation is a scalar multiplication of other, then this has infinitely many solutions. Basically, if we can multiply one equation by a number that which is a scalar number like 2, we will find the other one. So in this case, basically this line and this line is the same line. So both of them are different line, but they are basically, they have the same position, right? This line is the same, like they are coinciding with each other, they are top of another. So in this case, we will have infinitely many solutions. So we have another possibility, which is that we will have no solution of the system. For example, this one, if both of the line are, of course we can have multiple lines, more than 2. So if the lines are parallel and they never intersect, then in that case we will have no solution of the system. For example, x plus y equals 3, x plus y equals 5. In this case, these both of the lines are actually parallel. How do we know? If we like determine the slope of this line, and that will be what? Minus a by b, right? So that will be -1, and the slope of this line is also -1. So both of them are parallel. So that's how we know that this system has no solution. So these are like very small, like very tiny systems, right? We can have many like tens and hundreds of unknowns like x, y, z, and x1, x2, x3, x4, and a lot of unknowns and a lot of equations we can have, and we have to solve those bigger and giant systems, right? So later on we will learn something called Gauss elimination. Don't worry if you don't know this term. We will learn in the next elimination. So we will learn this method to solve larger systems later on. Okay. So if we like, this is the like least amount of system we can have. Like the system size is very small in this case, only 2D, right? This is actually 2D system. This is a 2D system. Basically, we have 2 unknowns. If we have 3 unknowns like x, y, and z, in that case we will have these possibilities. So instead, we had lines, right? For each equation we had one, like this is a line, this equation represents a line. But if we have x, y, and z, 3 unknowns, in that case we will have a plane for each equations like this. So we will have planes. So in this case also we can have 3 possibilities: no solution, and one solution, only one solution, and infinitely many solution. So every kind of system, however the system, like the size of the system is, we will have only 3 possibilities: no solution, one solution, and infinitely many solution. So in this case, in the like if we have if we have x, y, and z, or you can even write like this, like x1, x2, and x3. If we have 3 unknowns, then geometrically the system would like look like this. If each equation will represent a plane. So in that case, we can have no solution. If 3 planes are parallel to each other, we will have no solution. If 2 of them are parallel and one of them is intersecting, but they are intersecting, like one of them is intersecting here and another is intersecting in another place, so we have no common intersection, right? We have no common intersection, and two of them are parallel. So in that case, we will have no solution. And if none of them are parallel, but we have actually no common intersection, basically 2 of them are intersecting in one place and others are intersecting at other places. So we have no common intersection points, so we will have no solution. Also, if 2 of them coincide with each other and another of them is parallel to them, then in that case we will have no solution, because we will also have no common intersection point. we can have only one solution in this case if where am I, yeah, this is, so we can have only one solution if we have intersection point. In this case, this plane, this plane, and this plane, three of them has one common point, which is this point right here. This is the intersection point of three planes, right? So this point is actually a value of 3, is actually a value like if we say solution are S1, S2, and S3. This is a point in a 3D three-dimensional coordinate system, right? This point represent this like this. Okay, so in this case we will have only one solution because we have only one common intersection point. Also, we can have infinitely many solutions like this if like three planes has a intersection line, common intersection line. So this is a common intersection line. Three of them has a common intersection line, but this has no one solution. This has infinitely many solution. Why? Because this line has infinitely many points within it. So this line can go on and on and on. So it will have infinitely many points in it, right? Also, then intersection is a line. In this case, intersection is a line. But if we have the intersection as a point, then it will have only one solution. Okay. Then we can have also infinitely many solution if three of the planes coincide with each other. All of them are coincident, and in this case, intersection is a plane, is a whole plane itself. Okay. In this case, we will have infinitely many solution. Also, we can have infinitely many solution if two of them coincide. Like here, two of them were parallel, and one of them was two of them were coincident, and one of them were parallel. But in this case, two of them are coincident, and one of them is like have one common line, which is one common intersection line. So in this case, intersection is a line, so we have infinitely many solution. If we have no common intersections, we will have no solutions basically, and we have only one common intersection, which is a point. In that case, we will have one solution. If we have a common intersection, but that is a line, in that case, or plane, in that case, we will have infinitely many solutions. So geometrically, this is very not like, this is interesting to understand, right? If we understand this, then we will have a deeper understanding of the system, linear system. Okay. So we can also have a system represented by matrices. How is that possible? So this is very interesting. Look at this. This is called augmented matrix. Augmented matrix. So we have a system, right, which has three equations and three unknowns, x1, x2, and x3. So this is a system that we have. So we can represent this system as a matrix like this: 1, 1, 2, 2, 4, -3. By the way, this is also 9 and 1. You can have 3, 6, -5, and 0. So we can see that we are only taking the coefficients of the equation and the constant, right? And we are like creating a matrix which is called an augmented matrix. So we will use augmented matrix later on to solve large and larger systems. Okay, we will learn a specific method that we will come to that later. So just know that we can represent a whole system with a matrix. Okay, next. Yeah. Okay, let's try solving a simple system. The system is x plus y equals 3 and 2x minus y equals 1. So I think you all can solve this simple system. We have passed high school and we are university students, I hope. But let's try this. Okay. So we can use elimination method or substitution method. So those are very simple things. So if we say x equal to 3 minus y and replace the value of x here, then we can say 2 into 3 minus y equals 1. And that in that case, that will be 6 minus 6y minus y equals 1. And not 6y, sorry, 2y. Okay. Then we will have 6 there, and minus 3y equals minus 5. And the solution will be 5 by 3. Y will be 5 by 3. If we replace y here, then we will get, if we replace y there, by the way, so 3. So that will be 5 by 3, right? Y is what? 5 by 3. Okay. So x will be 3 minus 5 by 3. And that will be, I think that will be 3, 9 minus 5, and that will be 4 by 5, 4 by 3. Okay. So the answer will be what? 4 by 3 and 5 by 3. This is the solution set of this system. Okay. So this was a very simple system. We will have larger system. We will have like for example 10 equations and 10 unknowns. That will be 10x10, 10 by 10 matrix, right? How can we solve a system that has 10 unknowns? We cannot use substitution or elimination, right? We will learn. Okay, let's try solving a simple system. The system is x plus y equals 3 and 2x minus y equals 1. So I think you all can solve this simple system. We have passed high school and we are university students, I hope. But let's try this. Okay, so we can use elimination method or substitution method. So those are very simple things. So if we like cool method that will enable us to solve larger systems, and that is called Gaussian elimination. Okay, so in this lesson, so let's try solve these tiny systems, and drop your answers in the comments. So in this lesson, we introduced ourselves to linear systems and different types of solution that a linear system can have, and how to solve them. In the next video, we will explore Gaussian elimination, a powerful method to solve larger systems efficiently. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell. See you in the next lesson.